Yes, we are ignoring the fact that I'm literally sitting on my table, but you can't see that. It just looks like a cool background, which is, well, whiteboard and my biology notes. Can you tell I'm going slightly insane? So hi everyone. Welcome back to my channel. Again, I haven't posted in a long time. Completely my fault. I've been working kind of non-stop recently. But yeah, today is Saturday and I want to get work done today. I want to get a couple of past papers done. I want to get pretty much fully prepared for some of my A levels. Because they're coming up. They're coming up fast and yeah, I need to relieve some of that stress, feel good that I've got work done. Now, it is currently 10:30. I don't have a plan, but I've had my breakfast. I've already done some of my teaching for the day. I have had a coffee. I'm raring to go. And the first step is, I think I'm going to do a biology past paper. Because my biology is my first exam actually. And so, let's get going with some biology. Okay, so let me bring you through kind of how I do my past papers these days. I bought this this tablet for myself. It's going to be my laptop for university, and it's helping me with my revision here. No need to have one of these. This is just if you do have one, this is how I do it. This is how I make things work. So I get a new page. This is going to be where I put my past paper, I guess. This is going to be 2010. A2 2, and then I'm going to get the 2010 paper, usually from the CA website because that's the exam board I'm doing, but thankfully my biology teacher has put up extra papers from other years, so I'm going to print that to OneNote, and it'll take a little bit to print because it's a pretty big paper. There we go. And I'm going to print it into here, and the entire paper is now on my tablet ready for me to do the work. So, got my biology done. I went through the papers, did the questions that were relevant, and I got an 98%, so I'm pretty happy with that. It's good calm down motivator, I guess, for when I'm actually going to do my exam, that I can do it, I can do well. Next up is going to be chemistry, but I'm going to take a bit of a break first, and then I need to do some maths after that. But chemistry is going to be another long one because there's just a lot of questions to do in chemistry, but I'm going to see if I can get some chemistry papers and yeah, get those done. Okay, so just in my chemistry, and it went reasonably well. It went as expected. It was like that kind of decent mark range, so I'm happy about that. It's just I am so worried about the chemistry exam because it could go any way. It honestly could go really well or badly, and I have absolutely no idea which way it's going to go. So I just need to keep working on my chemistry and making sure it's as good as physically possible for that exam. I also have a chemistry practical, which is it's like next Monday, so that's the thing. I have to come and do a chemistry practical and a calculation by myself to see, if I get the grade. Can I do a practical, that kind of idea. And yeah, it's 1 o'clock. I'm not hungry, so I'm not going to have lunch just yet, but I'm going to do some further maths, probably statistics, and also mechanics. Now my mechanics teacher's cut down on the workload for mechanics, which I am so happy about, because mechanics is my worst. There's no question about that. And then I might do some pure maths as well. Ordinary maths should be fine. I'm doing enough practice in school really about that. So I'm going to do a bit of further maths today, and then I have some other stuff to get done after. Okay, so maybe a bit of a different angle, and we're going to do something very different. I am going to do a T-test with you and kind of explain what a T-test is, why I'm doing it. So this is A-level statistics, A-level further statistics. Now, biologists will know what a T-test is, maybe not to the same extent as I'm going to go into here because it's all completely by your own without prompted. You just have to do this. You can see it's worth 12 marks. It's a massive question, but a lot of statistics questions are really mark rich, I guess. So yeah, and this T-test is about 8 candidates doing an exam, I guess. The questions are always really random, really weird, so I'm just going to go for it. And we have 8 different candidates who did the same, or who did 2 different test papers. So they did like one and then they did another one, or something like that. Something along those lines. You don't really need to know the context, but I need to work out if the tests were the same level of difficulty. So how am I even going to start thinking about whether the tests are the same level of difficulty? Well, first of all, I am going to work out the differences in the scores. I want to see, is the average 0? If the average is 0, the tests are the same difficulty, and that's your thinking. So I'm going to start by making my differences. So this is just how I write my difference table, my difference list, and I'm just going to take them away from each other. So let me fill those in. I have done this earlier, so I didn't need to write it all in. 6, 14, 0, minus 4, minus 3. Okay, that's my difference table. It's just literally taking away the first one from the second, or take away the second one from the first one. You can do it in either order, it doesn't actually matter. And now what I'm going to do is I'm going to find my values by using the statistics mode of my calculator. It gives me them all, so I can just literally write them in. So sum of the differences is equal to 19. Sum of the differences squared is equal to 341. And then our average, well, we have 8 on our average is going to be sum of the differences divided by 8, which is 2.375. So d average equal, or d bar, is 2.375. Now, I need to work out what the variance is, and then I can work out the population variance, give a bit of an estimate of the population variance, which is basically if more than 8 people were to do this. In fact, if every single person was to do this test, then what would the variance be? What would the, I suppose, like, how wide would the scores be? How many people are getting far away from the average? That's kind of what variance means. Standard deviation is maybe something some people are more familiar with from GCSE Maths, and it's how far on average people are away from the average, that kind of idea. And so s squared, or variance, is equal to, now this is small s by the way, not big S, this is small s, it's equal to sum of the d squared, which is 341, I'll write this down, why not, 341 over 8 minus d bar squared, which is average squared, so I'm going to type that in, minus d bar 2.375 squared. I did not type that in correctly, I typed in a very wrong number, and you get 36.98, and then I want to work out the population variance. It's an estimate of the population variance, so this is my little symbol, and this is of d. You can write d, you don't have to write d, but I'm going to do that, and this is equal to 8/7 times s squared d. Why? I don't really know. It's statistics. They make these things up and everyone just goes with it. So let's do that. Multiply that by 8/7 and you get 42.26. I'll round that up to 46.27. Okay, now we've got this. We can now start our hypothesis test. So it says 5% level and it's a t-test. So carry out a hypothesis test. And it's not just a hypothesis test, rub that out, it's a t-test, and we have 8, so it's 7 degrees of freedom test. Now, we're seeing if the papers have the same level of difficulty. So if they're not of the same level of difficulty, one could be easier or one could be harder. So it's two-tailed. Two-tailed comes in slightly later when we look at our rejection criteria. Carry out a T7 test, two-tailed, at 5% level. That basically means we're going to be 95% sure of our outcome of this at 5% level. So now it's time for everyone's favourite part of biology. Our null hypothesis is that the papers are of the same difficulty, no significant difference in the difficulties of the papers. So we are saying that the mean is equal to 0. And then we can say our alternative hypothesis, there is a difference in standard of the papers, so our mean is not equal to 0. It could be higher, it could be lower, we don't really know. We're going to work it out. Oh, I just hit myself. We're going to work it out. So rejection criteria, we're going to reject H null, which is our null hypothesis, if our value for t is greater than, now I have my table here, I have to look at my table and find, now we're doing a 5% level test, it's two-tailed with 7 degrees of freedom, so I'm going to look at the 7 row. I'm going to look at 97.5%, gives me 2.365, because it's two-tailed, which means we're looking at the middle 95%, which means there are 2.5% on each side and it's symmetrical, kind of. So yeah, 2.365 is our critical value for t. Now, time to work out t. So t is equal to x minus mu, and our x is our average, which is 2.375. 2.375 minus mu, which is 0, divided by our variance, but it's our variance out of the number of people we have. So our variance is 42.27. 42.27 divided by 8, because that's the number of people we have in this test. And this is equal to 2.375 divided by 42.27 divided by 8. That comes out as 1.033. So our value for t is less than our critical value. So since this is always your little sum up thing at the end, since t modulus of t, means if it's positive or negative, it doesn't matter, is less than 2.365, we will not, this is always really waffly, we will not reject H null. Null hypothesis, we're not accepting you, but we're not rejecting you either. At the 5% level, always tie it back into the question, at the 5% level, there is enough evidence in, if I could spell, it would be really useful. There's enough evidence to suggest, remember this is all potential, potential what's left behind. There's enough evidence to suggest that the tests are, let me see, and you look back at the question, same level of difficulty, or of the same level or difficulty. And once you have that written down, that's you done. You have done your test. Now obviously I need to look at the mark scheme to see if I'm correct. Boom. So there you have it, that's statistics a thing. Let's put into this video because why not? Why not? So I hope you enjoyed that, found that useful. If you want me to do more stuff like that, then I'm perfectly willing to once my exams are over. But yeah, that was a statistics question, and it's lunchtime now, but my plan is to eat something for lunch, do some mechanics, because mechanics and I just don't get along. I've said this for 2 years at this point. Mechanics and I are not friends, and I need to really just get myself and my mechanics up to scratch so that I can go in and do this exam. As I said, some parts have been cut off, which is great because I only need to focus on 3 topics rather than like 6. Because we've already been tested on those, so there's no point testing us again on the same topics, because I mean they need evidence, and often they need a range of evidence, so like it's being like, here I did 3 tests that were exactly the same. No. But anyway, that's all the time I have for today. If you did like this video, don't forget to like, subscribe, leave a comment down below, do all that great stuff. But thank you all for watching, and I'll see you all in the next video. Bye.